So I just got back from React Conf, and if I'm being honest with you guys, I wasn't expecting a whole lot in terms of announcements. And on one hand, there really wasn't too much. But on the other, a lot of things are starting to change, and I feel like I'm getting a clearer picture of what the future of React looks like. And it's quite a bit different from what I had expected in the past, so want to take some time to talk about it. There was a lot of little things that have come up over the last few weeks, and any one of them isn't really worth a whole dedicated video, but the combination of all of them almost certainly is. So it's going to be a bit different from usual. Usually my videos go all in on one thing, like one blog post, one topic, one idea, but this is more about the things happening in React and around React, and most importantly, where I suspect we are going with the entire ecosystem. From the change in leadership for React, where it's now led by a foundation instead of just Meta, to all the fun view transitions and what this means for how we write React and use React going forward, to React Fur, which is the all-new rendering engine that may or may not ever ship. It was more a deep dive experimental attempt to make React even faster. React Router with server components, which, don't sleep on this, server components in React Router is possibly the path for server components for the majority of apps. As cool as Next.js is, there are a ton of projects that will never reasonably move off of React Router and like the old school Webpack config that they got from Create React App. And this is a path for them to modernize without having to move away from the tools they're already using and towards something like Next.js. React Native had a ton of cool things, in particular static Hermes, which is going to be really cool for a lot of things, especially potentially compiler. And of course, Remix v3, which is its own crazy rabbit hole that I'll do my best to not go down too far, but there is some stuff to cover. We've got a lot of stuff to talk about today, but only one sponsor, so let's hear from them really quick. Today's sponsor is an AI code reviewer. Wait, no, don't skip. Trust me, you want to hear this one, because they're not just another AI code reviewer that gives you sloppy, useless comments on your PRs. Everybody I've heard talking about Greptile has said that they are the best by far, which is why I decided to look into it. The CTO of Brex said that he's tried more code review tools than he can count. Greptile outperforms them all by a mile. It's the only AI reviewer that doesn't annoy the shit out of him. Gotta say, it's pretty cool to see Greptile doing the work of a whole team instantaneously with fixes and polite GitHub commentary, cleaning my data flows by default. I was skeptical when I saw all of these things, so I tried it myself, I enabled it in a bunch of PRs, and I immediately understood. The team told me to roast them when I tried it, so I went out of my way to hit every edge I could, and I couldn't find anything. It was super easy to set up. I went to the website, I signed in with GitHub, I added a repo, and it was reviewing things immediately. It reviewed all the changes I made on the Cloudflare versus Vercel bench, and it was honestly really nice to work with. We can see it tearing apart Ben's code here, drawing diagrams and all the other fun things, but my favorite thing is how it uses emojis. It's a small thing, but when I at Greptile, you'll see almost immediately it will react with eyes emojis to let you know it's seen something, and then it'll give you a thumbs up when it's done. See? Super convenient. It's minimal but tasteful, and that's been my experience with Greptile this whole time. What isn't minimal is the number of bugs they've prevented from shipping. One of my other sponsors, PostHug's, been using Greptile for a while, and I asked the Greptile team to find me some examples of potential outages that were prevented by Greptile. I expected like 2 or 3, and we can see some here. Like the date database field is used for hour bucket, but it needs to store hourly data, so it used the date time field instead. You're quite right. Or here, the cyclotron fetch package doesn't exist in the cargo workspace. That's going to cause this to fail. Updating to fix. Database operations not wrapped in transactions. If notebook creation succeeds but relationship creation fails, you'll have orphaned notebooks. We'll wrap it in a transaction. If this is all Greptile had done, it would have been worth it just to keep me from experiencing outages as a PostHug user. But it turns out there's been a lot more than that. The Greptile team sent me this spreadsheet with literally dozens upon dozens, maybe even over 100. Yeah, over 100 examples of outages that might have occurred if Greptile wasn't enabled on PostHog. That's kind of insane if you think about it. For $30 per month, that's not a bad deal, but if it's open source, it's fully free, and if it's a startup, it's 50% off. What do you have to lose? Check out the best code review available at soydev.link/Greptile. Let's start blasting through these topics. First, we have the React Foundation. This is a huge change for how React is being run, and I think it signifies some other potential changes long-term as well. The React Foundation is a group of companies, including Amazon, CallStack, Expo, Meta, Microsoft, Software Mansion, and Vercel, that are now going to run React together. If you're not familiar with these companies, I'll go through them quick. You might have heard of Amazon. I know they're kind of new. They're a shop for buying books and things online. I'm not really sure what Meta is, but okay, the ones you probably don't know about, if there's anything on here, are CallStack, Expo, and Software Mansion. CallStack and Software Mansion are 2 ecosystem maintainers and consultancy groups that do a lot of consulting for big React projects, in particular React Native. They help a lot with crazy projects like React Native for Mac and Windows, whatever the hell's going on PlayStation, just a lot of different deeper dive stuff. Software Mansion's done a lot of the work for the crazy animation libraries within the React Native ecosystem. Two great companies. And then Expo, the people making all the React Native tooling we use to spin up and distribute our React Native applications. All really good companies. I've had nothing but incredible interactions with all three of them. It makes a ton of sense to see them here alongside Microsoft, who's betting hard on React for Windows and Mac, Amazon, who's betting hard on React Native for like everything, and Vercel, who I guess has used React before. In their words, we open sourced React over a decade ago to help devs build great user experiences. From its earliest days, React has received substantial contributions from contributors outside of Meta. Over time, the number of contributors and the scope of their contributions has grown significantly. What started out as a tool developed for Meta has expanded into a project that spans multiple companies with regular contributions from across the ecosystem. React has outgrown the confines of any one company. To better serve the React community, we're announcing our plans to move React and React Native from Meta to a new React Foundation. As part of this change, we will also be implementing a new independent technical governance structure. We believe these changes will enable us to give React ecosystem projects more resources. I have thoughts here as well. How do I put this? In a world where company priorities change on like the flip of a coin, having one company owning something this big is a bit scary. Meta's changed their focus so many times recently that React isn't necessarily safe amongst the chaos. If your framework or tool is owned by one team at a company that is a very small team relative to the size of the company, the React team is very small relative to Meta. If that's the case, you're one reorg away from dying. And it's no secret that Meta's been going through a lot of reorgs recently. As a hedge to make sure that React will survive any chaos internally, any shakeup, any changes, any leadership moves, I like this a lot. Because a lot of us are betting on React, but Meta could change where their bets are going at any given time. This is all understanding incentives on a business level, but the harsh reality is that if any one of these companies now decided, oh, maybe React's the wrong thing. Like let's say Vercel moves to Svelte or Vue because they now have the SvelteKit team and the Nux team at Vercel. If they go away and stop focusing on React, we still have 6 other companies that are down. Same with Meta, Amazon, Callstack, Expo, Software Mansion, Microsoft. All of these companies are now going to help prevent any potential damage to React, as well as having more incentive to contribute to it. There's also a future where additional companies could come in. I also think it's worth talking about the fact that people have never understood how React was run. There's this weird perception that the React team is majority at Vercel and just a few people are left at Meta, when the truth is kind of the opposite. The majority of the contributions to React were still from Meta, but we've seen as much from Vercel as we have from Microsoft recently, especially if you count React Native stuff as well. There's been a lot of effort from other places, and this helps distribute the ownership across a larger group that are all going to be voting and making sure that React is going in the right direction for all of our needs. This also means things are going to move slower because there's now a much longer process to make things happen that involves way more people making decisions. But this should hopefully, fingers crossed, make the future of React a little bit more stable and brighter. I would also go as far as to say that if this was the structure before, something like server components might not have happened because the only companies here that are really interested in and really investing in server components are Vercel and very slightly Meta, because Meta kind of solved the same problem with the chaos of Relay before. So that's the React Foundation. Next, we have Vue transitions along with async React. We've touched on this stuff a little bit before, but Ricky's talks really emphasized how far it's gone. And when I say talks, it really was just one talk, but it was a talk with some weird splits.
How we doing? So while preparing for this talk, I dug deep into some of the history of React and found some old meeting notes from 2015 and 2016. 10 years ago, we started an ambitious project to rewrite the entire architecture of React to support incremental rendering. The team knew it was important and had conviction that it was the right direction, but there were a lot of ideas and opinions about what it would look like, and we had to understand it for ourselves.
I know way too much history here with Sebastian and Jordan's battle for how to make the new render model work. Wild, chaotic wars have happened in order to make all of this occur. And if you guys remember, Concurrent React was originally brought up in 2018. As crazy as that seems now, this was our first demo of it and showcasing of how the new rendering could hypothetically work. It was a big part of why hooks were introduced, as they would be theoretically easier to slice and run concurrently with the new model. And then Concurrent React kind of went a lot of different paths. There's a great video by UI.dev about the history of concurrent React, but the story's changed a little bit now because we now have what is effectively incremental React, or as they refer to it here, async React. Not just concurrency. There's a lot of other layers to it, and the result is a pretty different mental model.
These are not one-off features where you can just drop them in somewhere and they just work for that one specific use case. This is an entire re-architecture of how you think about building your apps by building them async first. So the problem here is we've added start transition, but it still performs the same as before, because fundamentally the issue is here in our use effect. We're not fetching the data until after we've already committed the results to the screen. Once we've committed the results of the completed state to the screen, then we fetch to get the new data. And you can solve this with a lot of different techniques, when like doing a client-side cache and using a store, and when it updates, you update your client cache. But that has problems in terms of maybe you have different tabs open, or there's different users changing the data. And that's why you'll end up hitting a lot of cases where you have conflicts with the server and the data that's actually in the database. So it's actually best to refetch everything from the server. But if you're going to refetch everything from the server, you need something to coordinate it for you. So let's replace this effect. And let's do that with suspense. So I'm going to do a little caching for promises. If anybody's familiar with use, you got to cache your promises. And that means we can delete some of this code. Let's delete this effect. Don't need that anymore. Let's update our revalidate function to clear the cache whenever we revalidate. And then when we update, we'll need to do that in a transition, just so that it's combined with any other transitions that we have. And our app's going to be broken for a minute. And then we can go to our lesson list. And now we don't have our lessons because we deleted it from above, but we can just use those. And now we don't need this fallback here. We can delete this. When we can use suspense for our fallback.
If I recall, this all breaks because of stupid small things.
I did miss this.
Yeah, there was a couple things. I think you just copy pasted the code in the end to make it work.
I heard this view transition API is pretty dope, and I can just do one line, right? Oh, that's really nice. It's pretty sick.
View transitions are so cool and they solve so many problems. Instead of managing like 15 states in the component doesn't exist until the data it needs is there. That's the key thing to think about differently with view transitions in suspense. The goal here is to take away a lot of the mental burden and like the component architectural burden that exists in so many applications today. Let me see if I can find a good example in a real code base of mine. Already found an example. Did not take long. We have 33 instances of is loading. In its current implementation, the status banner has a data state and it is loading state. And we have this check to return null if is loading. This one also has another case where we return null. But this is control flow that only has to exist because this component exists whether or not the data is there, and we have to handle the case in the component of when the data isn't there. The shift here is that the component itself can be treated asynchronously, so to speak, where the component doesn't exist until the data exists. And when you put a use call in, you're effectively saying, don't go any further until we have this. Previously with React, you would just render through every layer in the component. If something took too long, you'd let it go happen in the background and have a loading state in the component. And that control flow just kind of sucked, because if you do an early return, but you want to access another hook later, you're screwed. You can't assume the data exists because the data just might not exist yet. So ideally, I wouldn't have to handle this here. I could handle it higher up. If I had just is loading as the condition, I'll just delete this so you can understand what I'm trying to point out. Like if I have this here to get us out when in loading state, instead that can happen higher up. And it keeps us from having these pending states in here. So if instead I had like a loading spinner here or something, that's control flow that shouldn't belong to the component. The component should just not exist until all of the things it needs exist. And that's what view transitions plus suspense give you, is the suspense gives you the ability to treat the component like the data is already there when it does render, combined with view transitions, which gives you the ability to animate the different states. Because previously, if you wanted this to fade in or out or handle those cases, you'd have to do all of that in this component. So even if suspense let you pull the loading state out, you'd end up wanting it still to make a good fallback and animated experience between them. The combination of those two pieces gives you way fewer reasons to handle all this stuff in the component, which should hopefully make our components way simpler and as a result make our apps faster, because we don't have this hierarchy of loading like blockers preventing the entire tree from rendering.
All right, so now how does our transition working for the checking done? Let's try it. Nice. Mark these 3 done. It waits.
But you get the general idea here. There's one other really cool thing they did with all the suspense and view transition stuff. It'd be very easy to get yourself into a bad state where you're constantly having things pop in. If you click 3 buttons that do 3 things and they all take some amount of time to resolve and they end up resolving and completing their work within like 200 milliseconds of each other. If you don't do anything special, it's going to have a lot of pop in. You're going to have different UI changing in different places and the experience sucks. It's really, really bad for users to have a lot of change happening close to each other. So what React does is auto debounces. When you have lots of these transitions and fallbacks and suspense things going on, it'll wait for just a little bit to see if any more happen, and then everything will come in together at once, which is really, really nice. These are the little things that would have required a bunch of code and are kind of magic, so to speak. And I try to avoid magic and things as important as these tools and these frameworks. But the combination of view transitions and the behaviors Ricky is sharing in chat here, the transition waits for suspense to finish. So good. It lets you do all of these things that would otherwise pop in and be really tough to get good for the user, and makes it way simpler. There is some magic where some things will take longer than you might expect to resolve in the UI by like 1 to 200 milliseconds, but it's so much simpler. I wish there was more good code examples. I'm sure there will be plenty in the near future. I might even whip some up myself. But this is all part of the stuff that's in React Canary right now. React 19.2 does not have view transitions yet, but it's happening. There's also a lot of work going on with the Chrome team to make sure that this all can be a really good experience. And hopefully Safari and Firefox will have it ready to go by the time this is officially launched. But man, this is a really weird, I'm trying to remember how to put this. Like, this is the closest React has gone to like doing things for you on like the implementation details level in a lot of ways, where it's like much more opinionated than most React primitives are. But when you take some opinions, you end up simplifying a lot of things. When you build a framework with no opinions, the result is that everything is going to require a ton of boilerplate to do anything reasonable. But with opinions like, instead of having a loading state, you should have the data there and hoist the loading state up. Opinions like, if you have a lot of things loading at once, you should debounce the render so that they can all pop in together if it's within a reasonable amount of time. Instead of animating by doing different states inside of the components, you should animate by wrapping it with a view transition. These opinions lead us to a place where you can make something way simpler if your goals are aligned with the tooling and the way that it works. This should make a lot of stuff way easier to build and write and maintain. But the future is very exciting with this stuff. And I'm so hyped for view transitions. Even if the browser I'm using right now is Firefox based, so there'll be a iffy. Fingers crossed that will change in the near future. I think I've covered enough about async React and view transitions that deserves its own video in the near future. We got to talk about fur. Oh, React fur. This is right after my panel, funny enough. I actually haven't watched this since. I don't even know how I looked on the couch. There are very few cuts to me, at least in the highlight. Oh, there's me. The two things I think are going to be really important now is that, like with AI, the need to maintain a stable API is greater than ever, because you're not going to teach the LLM like, oh, we deprecated that API, stop writing that. Like, hypothetically, it could get better at these things, but that's me. You guys probably know who I am if you're here. But we want to talk about React Fur. React Fur is an exploration largely led by Joe, who's one of the leads on the React compiler work. He has been going hard for a long time now, trying to make React's performance as good as possible. Compiler is one strategy, which is to optimize the code the developers wrote to make it as efficient as possible within React and the rules of React. But what if you can do similar things within React itself? Very good talk.
For those who aren't familiar, incremental computation is an umbrella term for software systems that can efficiently update their outputs when their inputs change. Common examples are things like spreadsheets. You change one cell, only the cells that are actually use that update. Build systems and UI. React is an incremental UI system, despite what some folks might claim. Now, our approach on this was to create a series of benchmarks that are representative of different real-world scenarios. One of the challenges with benchmarks is obviously that you kind of end up focusing on one specific case, and we don't want to over-optimize because that's not representative, that one case isn't representative of all apps. So we created a whole bunch of different benchmarks. For this talk, I'm going to focus on just one, but I'll share kind of some of the broader results at the end.
Don't want to spend too much time on the specific test here. It renders a React logo by rendering a bunch of characters in a path, like one at a time. So it goes through one by one and renders each of them by having a higher up state object, like a context, that has updates that happen as quickly as they can. And every time the render completes, it adds the next thing. It's an interesting bench. It's really meant to just stress test how much throughput you can do with a higher level state solution like context or a global. Without it being a traditional global, it's just part at the top of the render tree. There's also a version of this bench he does in a signals-focused framework. Don't know if I'm supposed to say it's solid. I may or may not have seen the code, and it's pretty much one-to-one port of the React version, and it still uses context in solid, just a very high-up one in a way that you'd almost never do. This ended up in a lot of ways being a talk about data architecture and how it's just as important to keep track of how you're managing your data and your state in your apps as it is to render things and manage data like through your render tree the right way. Let's get to some of these fun results.
Text. So how much faster can we really get when every component has to update, at least somehow, right? Okay, so baseline, first, the results for React. Now, this version has minimal manual memoization. And remember, this is 5,000 interactions taking just shy of 4 seconds on my laptop. And here's the result for React compiler. Yeah. Not bad, right?
So the React compiler, it memoizes at every level, and I think he had a good diagram for this somewhere. It might come up later. But since you have the context and it's rendering all of the entities and passing IDs to each entity, and then the entity has to pull from context its value, the tree for what is getting updated is pretty brutal. Yeah, he shows it here. The value you get out of the compiler is that it can stop the update from going through at any given point via the memoization.
To make this type of application faster. So, first takeaway. React compiler can significantly improve the performance of context-based apps. Now, this is going to be a recurring question in this talk. Can we go faster?
Yes.
She's cheated. She's seen you saw the dry run. Doesn't count. Now, there's been a lot of noise about signals in the community.
I don't think noise is a fair way to refer to it, but I understand where you're coming from, Joe.
What if we use signals? I heard they're fast. So we built a prototype, a brand new approach to React, ground up rewrite of the runtime using signals. Or, well, not quite signals, close. Pull-based or lazy incremental computation graph. We extended React compiler to emit the code for this, translating existing React components and hooks to use this new runtime. Pretty cool, right? I'll talk about how this works in a moment. Signals. We've heard so much about signals, and I'm sure you are all really, really excited. Are you excited to see the results? Want to see the results? Okay.
I was so nervous doing this.
Yeah. I'm just as excited to show them to you, and not for the reason you're expecting. Our results so far.
Yeah. Signals performed worse. So I almost feel like I have to go into a deeper dive on how signals work. I've needed to for a while. The super simple TLDR version, as he talked about the lazy computing graph there, we go back to the diagram here. if this is like you have the component that has its style at the bottom here that is determined by its width and its height, which is how it knows how to and where to render. Traditionally in React, you would have this data at the top, somewhere high up in your component hierarchy, and it gets passed down through layers. And as a change occurs in that data, each layer gets the new data passed down to it. The way signals work is the opposite. Instead of from the top, data gets passed down, when data makes it to the end, it sets up a binding, almost like an event listener. And at the bottom, wherever this data is being consumed, in this case in style, because in the style tag for this element, we're setting the width and height based on the ones that are coming from context. When you set that up at that lower level, it'll create a binding to this entity such that when the entity changes, it goes through a list of all of the things relying on it and then updates those things. That's what they mean by pull-based. Instead of sending data down through the whole React component tree when it changes, every element that is touching something from state creates a binding when it touches that state so that it gets updated when the change occurs. Oh, I didn't know Ryan was still here. Awesome. Context doesn't impact what re-renders in solid. It's like if everything is an external store. Yes. So instead of the hierarchy of the data controlling what is rendering and re-rendering, the data exists externally and elements are bound to the data directly. So anything that changes gets updated itself. So if you had something like this, obviously this is like the hierarchy of how the components exist, not the way the data is actually passing through. If context provider had some value and this is being passed in as a sub value like this throughout, you get the idea. If the data goes to layer 1, then layer 1 mounts layer 2 mounts layer 3, and then something changes up here, like you have a use state up here, const value use state, cool. So you have this up here, you pass this value into the context provider, layer 1 consumes it, layer 2 consumes it, etc. The update has to go through each of the components to make sure any change isn't affecting that component. That's how React works. It is slow for the reasons that are hopefully intuitive to you, because it has to go through every single layer where something might be touched. This is why putting use states and context near the root of your app can be so destructive for performance, because if you put a use state at the top of your app and something changes, it has to go recompute every single layer throughout the React tree. This is a different way of showing essentially the same pattern. This is showing the data side, not the component side. But in React, the result's effectively the same thing, because in React, the component hierarchy is the data hierarchy, unless you're using external stores for said data. So you would expect signals to be faster in React, because now you're not checking each layer between the thing that uses the data and the thing that holds the data. You can skip layers 2, 3, 4, whatever, and just change the thing at the bottom.
So this is when we started to question our life choices. Maybe we're just not cut out for this. And then we regained our senses. And we double-checked. Okay, what if we just made a mistake? Because, that happens. So we took a signals-based virtual DOM-less library that scores well on popular benchmarks, and we ported draw to that library. The specific library doesn't really matter, as we'll see in a minute. Again, this is an experiment, so we're changing one variable at a time. So we're going to change the rendering, the rendering algorithm, so which means keeping the data model the same. So we use the same approach, state, passed down via context. And I want to call out, if you were to go and use a signals-based library, this isn't how they'd recommend storing your data, right? And so it might, you might say that, oh, this is an unfair comparison. But the whole point is we're doing an experiment to compare, given this data model, what performance characteristics do we see given for this rendering model? So.
And again, the data model being bad and the rendering model having some performance optimization opportunities are two separate things that I think it does a really good job of separating in the talk, and I want to make sure I continue to honor that. The way that you manage the data as the developer using this framework is important, and the rendering patterns that the framework itself uses are also important, but less so than you might think.
How's it look? Okay, maybe they're really fast, right? Signals are fast. All right. Our results so far? Wait, that wasn't, oh.
Yeah, I don't love how this is framed at a lot of points, like it should be fast, signals are fast, just unnecessary comments. But the core idea of the data model can trash almost any rendering model is really interesting.
Well, in both our incremental prototype and in a typical signals graph, you end up with something that looks very vaguely like that. I got tired of drawing boxes and aligning them, so I'm sorry, that's the best you get today.
Real.
On the left, we have our context, which really there's a state going into the context, but you get the idea. There's one giant input, and then we have a whole lot of derived computation. And then over here on the right, we have our places where we're going to use these values in our UI tree. See, it looks sort of like a tree over there. So to propagate a change, we need two phases, because these nodes in the middle, we only want to compute them once, right? If a node has two inputs, we don't want to compute it twice, first with only half of the inputs updated, and then again when all the inputs are updated. We want to make sure we compute each node at the right time, only when its inputs have been updated. So there's a very specific set of nodes in this case, you need to pay close attention to this, that are affected when this context changes. So watch closely, it's all of them. Okay, so first we'll just mark them as changed. We're not actually recomputing here, we're just marking them as changed. And then we'll go walk this tree and say, give me the latest value.
Oh boy, arguments potentially brewing in chat. Chill, guys. I want to bridge the gap here because I see both sides on this one. I've absolutely seen developers do what this is doing. So let me just make a new project for this quick. So the problem with this here is that we now need to, wherever we're consuming this, deal with the list of entities. So if I make the list component, and this is where all of these entities are rendered. Cool. There's an annoying problem here. Since the entities are rendered here as part of the whole group of entities, adding a new one requires you check all the old ones. So if this div was an expensive component to render, or there were theoretically a ton of these components to render, every time a new entity is added, or worse, an entity is changed, this here has to be recomputed. The result might be a no-op, but this layer here going through all of the items, even if one item changed, this breaks. Since all of the items are rendered here through a check on this higher level entities, the result here is that any change to this results in everything changing. There are a lot of different data architectures to help you get around this reality, but this is reality. So it means if we go back to the diagram we had before, if this element changes, like let's say you change width or height of one of the entities, maybe you change width or height of entity 256 out of 5,000, all 5,000 nodes have to be re-rendered, even if it is opted out of really early via memoization, because this layer here, the one that maps all of these entities into the DOM, has broken when entities itself changes. The problem is that entities is an array, so any element in entities changing results in the whole array being busted. This is a bad data model that results in bad performance in basically every rendering strat, and I've seen so much code written like this, it's hilarious. And in most cases, it's fine. But when you're intentionally pushing it as far as possible, this isn't going to be great. And that's why every render strategy struggles when you hoist the context up and then have everything in one array where any element changing busts the whole array. With legend state, you have an observable helper that can take an array, and when you push something new, can debounce the change so you don't end up with the whole array re-rendering. You do have to use their custom for component in order to handle this, because they will only update the element that is changed for you. It's not for as in for each. It literally is, but it will handle the diffing and the prevention of the update for you as well. So other solutions for state handle this in their own unique ways. There's a lot of good stuff in Legend worth referencing. It's a really good library. Jay is incredible. Back here, though.
But maybe ChatGPT can explain it to you. We're just going to skip over the high level here. But the point is, we're actually visiting the graph again.
One other good point from chat. Thank you, Rick. The pithy way to explain Joe's point is that fine-grained updates aren't enough. You need fine-grained data modeling, too. The nice thing about signals compared to context is that it's more common to do fine-grained data modeling. Absolutely agree there. I find that a lot of the performance comparisons that we see just aren't very good, because the performance comparisons are focused on what does it look like if you write the best code in each framework. And there are certain frameworks where the best code will be better, but there's also certain frameworks where more people are more likely to write the better code. And React is not one of those frameworks. The average React code base is a shit show because the average React dev is just using React because it's what they were told to use, they didn't pick it. The average Solid dev is way better. And on top of that, the mindset that Solid encourages is one where you're making things more fine-grained. You're using the built-ins to break up your data model in a better, more intelligent way. And the result is much better performance.
Domain-specific approaches can often outperform generic incremental approaches. Signals are a very general-purpose algorithm for incremental computation, but we can do something a bit more fancy. So fast forward at least a year. Numerous prototypes created and thrown away with, gotta say, amazing engineering work, incredibly clever designs that just did not pan out until we hit upon a variant that we're calling React Fur. It's a novel approach to incremental rendering that uses a hybrid eager-lazy algorithm. Now, it's important to note this prototype does not support all the features of React, but it does support a lot of common patterns, more than enough to render the draw benchmark. That said, before you get too excited, this is a constrained prototype. It is a long way away from shipping. But we wanted to see, if we do kind of strip things down to the core, how fast can we make it? And that was the idea here. So this time, you're probably excited for the right reason. Yeah. Couple years of work to get there. We were pretty impressed, pretty happy. Now, a new React code name, a novel incremental algorithm. You probably have a lot of questions. You have questions? Yeah? Okay. I guarantee the one you're thinking of is not this.
The can we go faster joke was really good. He didn't give much info on Fur. I don't know how far they plan to go with it. But again, there's the two pieces. Thus far, everything has been this rough data model where everything is in the same single array that all of the components and all of the entity bindings have to check from. What if you fix the data model? How do things change?
But what if we change the data model? So throw it all away, back to the basics, React. React compiler, a simple external store. What do I mean by that? Well, we'll define a store that looks something like this. It's got a get function to look up the current value of a drawing entity, a function to subscribe for updates to that value, and a way to publish updates to a few records at a time. And then we'll write a little hook that lets us read and subscribe to this store. Basically, I'm writing my own use sync external store here. There's a bunch of to-dos, but you get the idea. All right, so again, our results so far. And now, oh wait, that's right.
Yeah. He changed the title to be comparison because now the data model is different, so it's not really an experiment.
I forgot. Point of the comparison, but still, what are the results?
Okay. Case in point, fixing your data model, moving the store externally, and then binding the things that need to update to that external store instead of going through the entire render tree to get it there is significantly better. The actual signals implementation is already at this amazing perf today. Interesting. Potentially, I'd be very curious to see, like you're effectively DIYing signals when you do the external store to an extent, but you're subscribing by hand. So updates only trigger when the subscription gets updated. So instead of a subscription occurring whenever you access the data, like if we were to do this in Solid, we would bind directly. It would be like the for component, each entities would be hit as a function, which is what creates the binding. That's the difference, and that's where the binding is created. But if we don't want to bind there, if we just bind inside of the elements directly, like in this code, we bind the subscription to updates to this entity, then other entities will not trigger anything. Hypothetically.
Oh yeah. And we barely, we slightly rewrote things to use a store, but we're not like dramatically rewriting the code. And in particular, because of the subscribe function, we can do very targeted updates in this store. So why is this so fast? Well, if we go back to the incremental computation graph that we looked at for kind of the signal style graph, the issue was that the context was kind of upstream of everything. And so when that changed, too much work downstream got invalidated. When we shift to a store, it's kind of like we can see inside that context. And so now when one entity changes, we're just invalidating way less work and doing a lot less downstream. We're far enough along in the talk that you know what I'm going to say next. Yeah, there you go. All right. In particular, what if we combine these ideas? Because I just said when we changed the rendering algorithm and we changed the data model, I'm like, can't you do both? You can. So React for similar external store. Here's where we are so far. Yeah.
I will say, I would virtually guarantee if we did the same data architecture change, that Solid would be even smaller on this. Regardless, I think this talk has highlighted the point that your render strategy isn't going to take a slow app and make it faster if the reason it's slow is the data model, which historically speaking, the majority of the applications I have seen that are running terribly that are built in React aren't because React's render model is slow. It's because the state management that they chose to do and the way that their data model's architected is really bad. I should have mentioned this earlier, but I will now. This should not be treated as an announcement, as confirmation that certain work is going to be done or that something's going to come to React. This is meant to be an exploration, and what Joe's doing here is meant to be sharing the exploration work that they've been doing. On one hand, in order to get people to stop replying to them, but have you looked at signals yet? I bet signals would make React faster. And on the other hand, to try and show that they are putting a lot of work in here to share their findings and start a hopefully better conversation that might, maybe, hopefully, fingers crossed, lead to developers being more aware of the data model they're using for their state and thinking about it a little more deeply instead of just shoving thousands of entities into a context and being mad when their apps are slow. Because that's what ends up happening more often than not. The vast majority of the time I hear people complaining about React and I go look at the code, they're doing nasty stuff with state that would be slightly harder in other frameworks, absolutely. It would be 10 to 50% faster in other frameworks, perhaps, but it wouldn't solve the data architecture problem unless they solve it themselves. So Fur is not a new thing that you should expect to install in your React apps so much as a really good exploration that the team did to showcase what they're thinking about, how they're working, and reset the conversation that we're having about React performance.
I did not believe that number when I saw it. Really hope it's right. Okay, now this is the point where we have to go back. Remember how I emphasized the highly, like triple, highly, super simplified at the beginning of the talk? This is a highly simplified benchmark. That makes it really great for optimizing the innermost workings of the rendering algorithm, but it also makes it less representative of real-world scenarios. So we also created other benchmarks that have a richer set of components and a more realistic data model. The draw was basically a key value store, as we saw. Now, these other benchmarks are, again, not all the way to a real app, but they're much more representative, and the results there were not quite as good. So this is a different benchmark, again, with React compiler in a store, and then React Fur in a store. And we can see that it is still a performance improvement, but not quite the same magnitude as we were seeing on the Draw app, right? This is just as we increase the complexity of our app, the rendering algorithm just becomes less critical to the performance. And there's just only so much we can actually make faster. And there's another aspect, too. Yes, it's faster, but it's not the full React. All right? And from a couple of years of experiments, we know that adding back some features that people rely on every day with React would, or at least could, eat into these wins.
Okay, I'll let him make his joke here because it's a good joke.
What am I asked next? No, it's time for a break. Okay.
Very good cut for the end of his talk. I agree with this a lot. The idea that somebody would line for line rewrite the React version in Solid is not real at all. You would be much more likely to do this correctly in Solid than you would be in React due to the nature of the frameworks and the primitives that they provide. To Joe's credit, Solid was not mentioned at any point. It was more meant to be used as a reference for a good signals implementation with the existing bad data model. It is out of respect for Solid that it was used for this because Solid is a really good implementation of signals. And if the goal is to take a bad data model and see if signals fixes it or not, Solid is the best way to check that. But the way the talk's presented does feel like a bigger dunk on signals than it needs to be, because I would bet that in that final realistic benchmark here, if you wrote this benchmark the React way, the React with an external store way, and the Solid.js way, Solid would have the best numbers by far. And I'm really excited for source code for these things to come out so that we can have a conversation as a community about all of this, because that will certainly be its own dedicated video in the future, but it's already taken up too much of this video and there's other things we have to talk about. So let's go to everything else. Oh, and of course, if you want more info on all of this, the person you're looking for is Ryan. Ryan does a stream every Friday and goes deep on these things. He did one 2 weeks ago with Ricky, who is here, and he just did one about all of the stuff going on, both with the React conference as well as with Remix v3, which we'll talk about in a little bit. And the first half of this stream was all about the Signal stuff. So check that out. Check out his follow-ups, and I'm sure he'll do once we have more of this data and once we have these benchmarks out or recreate them ourselves. I was really tempted to recreate them myself, but haven't had any free time at all. We got to go back in for the next pieces. And now we have React Router with server components. I made some bold claims earlier about this, and I'm going to defend them. I'm really tempted to show the talk that Kent did about this, but you should go check that out yourself if you're interested. I'm just going to show you guys the magic directly. We now have a real basic React Router app. Right now, these components run on the client. It's really easy to confirm this by going into the client, finding some random route. Here are routes, home TSX. And in here, console.log, we are home. And if I go to the browser and we open up the browser console, you'll see we are home gets logged because we are home is rendering in the browser. Let's say we have some complex components. We'll do function, complex, children. This will return, sure. And we render a bunch of these. Long array equals, okay, well, don't need that many things. We'll do 100 entities. Long array.map, complex children key equals item, cool. And now this should render all of these. And if I put a log in the complex component, console.log, complex children, we will see this logs 100 times because it's in there 100 times. Cool. If we're pretending this is actually complex or it's doing some actual work, not something we necessarily want on the client. What's really cool with the new server component stuff in React Router is how easy it is to turn on and then how easy it is to adopt in different ways depending on what you're specifically looking for. So the way you move over is you switch from the React Router config. So we have React Router here, standard from React Router dev vite. And we switch this over to use the unstable React Router RSC. It's just bound here to give the name something a little bit cleaner. Cool. That's the change. Is this a different like experimental version of React Router, or can I just copy paste that? Okay, it looks like I should just be able to copy paste it. Let me do that. See if it works. And now, oh great. What's going wrong? Okay, I'm just going to use theirs instead. I tried. Oh, so I need the RSC as well. That's what it was, almost certainly. I'm stupid. There should be an error for that. I also need the plugin installed. Screw it. I'm just going to go with the other code base that already has it all working. App, routes, home, yoink, yoink. Not using that anymore. Cool. Now this is rendering. Now we have complex children. Still everything's the same though. Cool. So we turned on server components. Where are server components? There's a couple ways we can access them. Here is the unique way that they do that I think is really cool. Right now we're returning this data from the loader. So we could have like use loader data and get some stuff here. So if we want const data, we have to import use loader data. I don't think it's smart enough to type this, but the type is whatever we return from here. So if I console log that here, we'll see that the data we get back is not showing there, huh? Let me comment this out, just clean up the logs a bit. Data coming back is null. What am I doing wrong with that? I haven't used, oh, that's just meta? Oh, that's meta. Oh, my bad. Export function loader. Thank you, guys. Cool. Yeah, meta is not loader. I'm just used to the remix pattern of having the one loader function up top and occasionally the mutation as well. Cool. So we have meta for the metadata for the page. Now we have loader, which returns that message. And if we go here, you'll see we have message, hello from loader. Awesome. Let's say we don't just want data here, though, because we can use this with a fetcher to go get data from a database. We can run this on the server. There's a lot of things we can do in the loader. Let's say we just want to render all of these complex components. So if I uncomment that, you'll see this is all happening on client. Let's do it. We take this content Move this up as well for posterity's sake. And then in here, we will render data.content. I'm not handling keys properly. That's fun. Oh, key is item. I need it to be the index. Cool. There we go. And now the log doesn't happen on client because all of this data is coming from the server loader. So these components are rendering on server. So they can't be interactive, but if you don't need them to be, if you have some data that's static, there you go. Now that static data is handled on the server side, and the client side can do whatever you need to. You could still do client-side code here. Count, set count, use state, and I'll create a counter underneath. And now on the same page, I can have client-side components. The root component, by the way, like the root of this page, home here, is a client-side component, but it's getting loader data from the server side, which rendered some data in it there. So now some parts of our app are static and server rendered, and some app parts are dynamic and client rendered. Traditionally with server components, you've needed to wrap the entire app with the server component because it has to come from root. That's still kind of happening here because React Router does own the whole React tree, so to speak. What's really interesting about this implementation is that you can much more, on the dev side, piecemeal some parts server, some parts client. An example where this would be really useful is if you have a page that's like your terms and conditions page. If you're doing that on client components, now you have that data on the server and the client, and the result is that you have it in your HTML and in your JS, which isn't ideal. If you move to this pattern for certain things, now that data can be server-side exclusively, and it only comes down in the HTML. You don't need the components to manage all of that. But let's say you don't want to use the loader pattern. You like the more traditional method that exists within the new Next.js React stuff. We'll make a new route for hardcore. Is what I'll name this one. Cool. Hardcore. I have to go add this to routes. It's not going to do the thing where it auto updates. I don't think it will. Does this ever say, like, how do the... I'm not as familiar with the new, like, framework mode React Router, like how it binds routes. Okay, here. That's what I thought. Route, and it needs a path. So let's do the same thing again in this new file. But I don't want to do it through here anymore. I don't want the loader at all. Export default async function. And then in here where we have data.content, do that. And now when I refresh, oh, an error. An unknown component is an async client component. Only server components can be async. Yes. Good error. Better than what we would get in Next.js, funny enough. That's because we have our useState here, and this useState call is going to turn this into a client component. In fact, many hooks will. We don't need the data anymore because we're not using it, so I'll just remove that. But we do want that counter. So how do we handle that? I'll make a new file, components/counter, TSX. We don't need a custom hook for this. Yoink that. We will yoink this bit and make it a fragment. Cool. And now we can go mount this here instead. Gotta import, save, load, and still an error? Oh yeah, there's one last thing we forgot. Use client. And now, did I leave it? No? That should be good now. It's because that's imported. Is it that this isn't async? Nope. That should have just worked. Export server component. Does that have to have a special name? Ah, that's the piece I missed. You have to export a server component instead of a default export. That's a little silly. Don't like the naming, but here we are. We are home, complex children. These are happening on the server. That's why it has that prefix. It passes the logs over, but there is no client log happening here. And we still have the interactivity with the click me at the bottom here that behaves as expected. Don't love the magic variable names, but that's the only issue I have here. The rest is actually quite good. I'm impressed. I think this is the path forward for most people to adopt server components for a lot of different things. Because a lot of apps have some amount of static on the outside. Let's say some of your routes need specific fonts and others don't. That can now be handled here. Let's say some routes need to fetch some data before they render anything and others don't. That can be handled here. Let's say some routes have a giant component with a ton of text that isn't interactive at all. You can do that here, and you don't have to manage that in the JavaScript anymore or wait for another network request. This gives you a really solid starting point for getting some data out of React, some rendering out of React, and either making it static and loaded from a CDN, or making it dynamic and loading it from a server so that you don't need to load so much JavaScript on the client. This is a really happy path to get there for most apps. And if you want some of the benefits of server components without moving everything to App Router and Next.js, we have a much happier path to do that here. I honestly see a way for a company like Twitch, knowing the chaos that is the Twitch web code base, they could actually start adopting server components for some things by moving over to this pattern. Really, really cool. And now we have React Native. For what it's worth, there wasn't too much new things announced with React Native so much as the path forward for existing things. All new Expo projects and all new React Native projects initted today will be starting with the new async bridge. It's not even an async bridge anymore. It's a synchronous bridge. I learned a really fun piece of information about this bridge when I was there. If you're not familiar, the way that React Native and Native communicate is through a bridge that allows for React Native to send messages to the native layer. That bridge is async. And the reason why was actually really funny to learn. The reason it started as an async bridge is they wanted the ability to debug the JavaScript using Chrome on your computer when you were testing your native device. So if you normally have a device like your phone, and in here you have like the native bindings. So here we'll say like this is AppKit or whatever. And then you have React Native, which is where all your JavaScript is here. These have to communicate. If this is like your phone, React Native has to send commands to AppKit, and AppKit has to respond. It's not quite this simple. AppKit's wrapped with a ton of different things. The binding between them is super complex, but you get the general idea. React Native is sending commands to something in native and then getting responses. There's no memory sharing. This is just an event message passing system. This could have been done synchronously, though, because you do have direct access to all of this. But if you want to get your logs on another device, like Chrome on dev machine, you could pass the logs over to the dev machine, but you're not going to get the level of granularity for debugging that most people would want. The fun thing that Fuchs, Christopher, creator of React Native and Prettier, and a ton of other random things, including Excalibur, the app I'm using for drawing all of this out, Fuchs has touched fucking everything in the space. It's crazy. If you wanted to debug the React and JavaScript part using Chrome DevTools, you can. They never went very far with this, but it was a thing that people used for a little bit. But in order for you to do a network hop to get the command over to native and vice versa, this now has to be async. And a significant portion of why the bridge between React Native and the native bindings on most platforms was asynchronous is because it had to have the ability to do the network hop, thereby making it asynchronous. This is a thing that both Fuchs and others have expressed immense regret about, and it took years for them to rebuild the bridge in the layer between the native engines and the native layers on your platform and React, to the point where they now call it bridgeless because you're just accessing values directly in the native code, and it is comically faster for a ton of different things. It's now stable enough that it's the recommended solution everywhere. It's what they're using everywhere. It's gotten really, really good. And a lot of those performance issues we were concerned about with React Native have been destroyed immediately through the removal of that bridge. This is a thing that's been going on for a while. I've talked about it in many other videos, but seeing it on stage said, nope, we're done. This is ready. You can use it today. This is the default going forward. Huge. And a lot of poor library authors have had to maintain two versions of their libraries for things like fancy animations. One would use the old architecture, one would use the new architecture. And companies like Shopify have been maintaining their libraries for both, but now have went all in on the new bindings. I know that this came up a bit. They're also overhauling React Native DevTools, which is super necessary. They're moving to a standard DOM API, which should allow us to share a lot more between web and mobile. As they said, React Native's native, but it's aligned with the web. Let's just hear this part because it's cool.
So that's why today, starting from React Native 0.82, it's time to make the new architecture the only architecture. Or more simply, the React Native architecture. Having a single architecture has a lot of benefits, of course. The first one that we discover is bundle size reduction. So in our preliminary test, we have seen an improvement in bundle sizes for React Native up to 1 megabyte. And the second benefit is build time reduction. In iOS, for example, where we don't have precompiled binaries as default just yet, our example application went from 300 seconds to build to 140 seconds. Having a single architecture gives you a simpler mental model for you as an app developer or a library maintainer. You don't have to worry about the next library that you want to use in your app, whether it will work with the current architecture of your app.
If you guys on the web think that new React updates are annoying to maintain in your projects, you have no idea how much worse it is in React Native. And things are so much better now. I want to find, there was a slide somewhere about how much faster things were for Shopify. I'm not going to hunt to find that, but there have been a lot of apps that moved over to the new architecture that have been very successful with it. The performance wins are crazy. The tooling stuff is really good now for dev tools in particular. Performance is a core priority for the team. And there's one last big piece of the performance stuff, which is the next thing on my list. Static Hermes. Hermes, however you're supposed to pronounce it. Every time I hear someone on or off the team say it, they say it a different way. Hermes is the engine that is used for JavaScript in React Native. It's an alternative to something like V8 that has different goals. Hermes is trying to be the fastest runtime for JavaScript, starting from nothing. Like spinning it up as quick as possible, getting everything you need into memory and launching your app faster because you don't have an engine already running like you do on other platforms. When you're building an app with Node, the assumption is that Node's already running and it's loading your code. When you're building on Cloudflare, the assumption is that V8 is already running and you're building code on top of it. When you're running an application in the web, you already have an engine running and you're just throwing JavaScript at it. But on mobile, there is no shared JavaScript runtime that you can just load JS code into. And if there was, it would be a shit show because every mobile app is going to behave entirely differently, which means that for a long time, most React Native apps would embed V8 in them to be the JavaScript engine. But V8 does not init really fast. It does not handle memory as well as you might want it to. It's a great, incredible engine that does things that are unfathomable. There's a reason everyone's building their shit around it. But it wasn't the right solution for mobile apps that need a fast launch time, which is why the React team and many around them have invested heavily in Hermes in order to make a better engine for the needs of mobile applications. And now they're going way further with static Hermes. There was one last announcement with Hermes I want to make sure that we cover here.
We didn't talk about over the keynote today. And this thing is Hermes. Hermes is our JavaScript engine tailored specifically to improve performances of React Native application. And today we have another announcement for you guys, and that is Hermes V1. Hermes V1 is the next evolution of our JavaScript engine with improvements on the virtual machine and the compiler for better performance. It is the foundation for just-in-time compilation and JavaScript to native compilation, something that we presented in the past couple of years under the name of Static Hermes.
I want to find, Sebastian did a really funny post about this. I don't know if it was his, but Hermes, Static Hermes, Hermes 2.0, Hermes V1. Oh, man. Oh, man.
As I mentioned that Hermes V1 comes with performance improvement, but here are the data to prove that. We ran Hermes V1 comparing it against the current version of Hermes with a set of synthetic benchmark from the JavaScript ecosystem, and we have seen Hermes V1 outperforming current version of Hermes across the board, and with an average improvement of 60%. But as Joe Savona mentioned yesterday during his talk, synthetic benchmark only tells part of the story, right? So we also try to enable Hermes V1 in a real-world, complex application, which is completely open source, the Expensify app. And we measure a few metrics such as total time to interactive, bundle time loading, and content time to interactive. And we have seen improvements in Hermes V1 against current version of Hermes up to 9%. We also run the same test using low-end Android devices, and we have seen similar improvements on the same metrics up to 7.6%.
The bundle time being 1.5 seconds and time to interact being 6+ seconds on an old Android phone hurts me deeply. But yeah, since this is its own JavaScript engine, there's a lot of features that are not included or weren't included, but they've caught up a ton. A lot of React Native apps will be bundled and polyfilled to all hell in order to get around the fact that Hermes has fewer features, but we're getting a lot closer. They didn't even have async functions until recently, which is kind of crazy.
Decatting those features in your TypeScript code, but today they are going through Babel plugins and polyfills. Hermes v1 supports those natively. That means that we can get rid of all the polyfills, embrace smaller bundles, and faster loading time for your app. It's available starting today.
Okay, I thought there was something about static here. I want to be very clear about this. Hermes, the engine we just talked about, the thing that's an alternative V8, is not static Hermes, which is an attempt to compile our JavaScript code to be assembly, to be native code. Static Hermes is not something that we expect people to run on their entire app. You're not going to compile your whole app down to native using it. What it could be used for is compiling specific libraries and other things that benefit a lot from best-in-class performance. For example, some of the state management libraries we use, some of the animation libraries we use, or potentially the React compiler itself. There's been a lot of talk about how we can make React compiler faster and easier to integrate with other tools since everything else is moving to Rust. React compiler being in Babel is kind of annoying. Wouldn't it be cool if we could take the JavaScript that runs across all of that and compile it down to native? Be a really nice potential feature where we can still write JavaScript and the result is super fast. We might be limited about what things we are and aren't allowed to touch. You might not be able to just import any library freely. But if more of our dependencies can be written in the right subset of TypeScript to be compiled down to assembly, those can now be run alongside our applications to speed up the things that are the most annoying in our code bases. Thank you, Gabriel, for finding this. I was looking for this earlier. 10% faster Android launch times with the new architecture with React Native. Really good stuff. So the combination of the overhaul of the actual runtime and the changes to how React Native binds to that native layer has resulted in pretty significant performance wins across the board and certain patterns that would have made no sense before, making a lot more sense because the bridge is cheaper now, which is huge. No worries, Gabriel. Appreciate you a ton. I think that covers most of these things. What is left is Remix v3. So React Conf was Tuesday and Wednesday, and then Remix Conf was Friday the same week. So there was just a lot going on. But Remix v3 has moved off of React entirely. They're still using JSX, but they're building their own layer for doing updates. Instead of your components updating when the data changes, you have to call this.update in the components. Very different mental model, really trying to lean into web standard stuff. It's also the only framework I've seen showcasing this, like the keyword this, in modern history. So we will save Remix v3 for when they have actual documentation out so I can play with it properly instead of speculatively like I would have to right now. It's not a React framework anymore though, so it barely even fits in here. Also VeeConf, yeah, it's been crazy. It was a wild week. So much happened in the web dev world. I'm doing my best to keep up with it all. I just got the Bun 1.3 video out. We're getting this one out right after. Again, no one massive thing, but a bunch of these small to medium-sized things that resulted in a much clearer picture of what the future of React looks like. The focus is a little hard to describe, but the best I can put it, we're trying to find out how to make the React code we already have run faster and better, while also making React simpler to write without changing the way we write it too much. The biggest thing in here that changes the actual syntax in the code we're writing is view transitions in async React. And if all goes well there, it will be a pure simplification of our code bases. But everything else here shouldn't change how we write code. It should just change how well our code runs and how powerful and performant our applications are. And hopefully we don't have to relearn anything because then the AI is going to have to relearn it too. Yes, I actually made it this far without saying the word AI. Aren't you proud? We're what, like 2 hours in? Yeah. Anyways, that's all I got for this one. What a chaotic journey it's been. Hope you guys enjoyed it as much as I did. And until next time, peace nerds.